So, good evening. In our last videos, I think we discussed very clearly about various sorting techniques like bubble sort, insertion sort, selection sort. So, next and after that, we covered counting sort also. Now, in today's session, we are going to talk about radix sort. I think already the algorithm I explained. If you want, let us have one example so that you can get the idea of radix sort. See, this radix sort is internally is going to use counting sort technique only. For example, consider I am having some numbers like 456, then 230. So next and after that 98. So next and after that triple three. Next and after that triple eight. Next and after that triple two. Next and after that triple one. So next we have 34. Next we have 9. Consider we have some elements are there like this. So what we are going to do is, in the first case, we are going to identify the numbers based on its unit positions. Unit positions in the sense what? In every number, so the beginning digit, last, in the right to left direction, the last number is called as always unit number. So the first step is nothing but you have to sort the data based on that unit bit position. Now, if you sort based on unit digits, then which one will come first? So, for easy understanding purpose, what I am going to do is I will write these numbers in a 3-digit format, because in this the highest number what we have, maximum number what we have here is 888. That's why I am going to take highest maximum value as a 888. So how many digits are there in 888? 3 digits. So I will try to represent every number in the form of a 3-digit number. Even if you have a double digit number, we will take it as 09. Okay. So I'm going to take 333, and we are going to take 888. We are going to take 222. We are going to take 111. We are going to take 034. We are going to take 009. Like this we have. This is nothing but what we have. Sir, now what we have to do? So these are nothing but unit positions, right? Based on this, we have to perform sorting algorithm. Based on this, we have to perform sorting algorithm. Sir, now among these, which one is going to come first? So this 230 will come first. Okay, let us see 230. So is there any other digits which are ending with 0? You have to identify. I think there is no other digits which are ending with 0. Next, identify the digits which are ending with 1. So we have one digit is there, which is nothing but 111. Next, is there any other digit ending with 111? 1? No. And identify the digits which are ending with 2. You can able to see we have 222. Identify the numbers which are ending with 3. I think we have 333. Identify the numbers which are ending with 4. So we have 034 is there. Identify the numbers which are ending with 5. I think there is no number. Identify the numbers ending with 6. 456. Identify the numbers which are ending with 7. We don't have any number. Identify the numbers which are ending with 8. 098. Identify the numbers which are ending with 8. One more number is there. So ending with 9. 009. Like this we are going to get. So from this, how we got, okay, so from first bit to second bit, how we got, I think you people got a very clear clarity. So we performed sorting operation based on unit position. And if you take unit position, what will be the digits in the unit position? 0 to 9. See, whenever the numbers are fixed, then we can always go for which sorting technique? Counting sorting. That is the reason why internally radix sort is going to use counting sort. When we have to go for counting sort, if you want to sort the data between the numbers, like I have a binary list is there. In that every number is a binary number. I want to sort that. How you have to do? You need to go for counting sort with the two elements 0 and 1. How many times 0 is appeared we have to count. How many times 1 is appeared we have to count. Based on that we are going to print. That is nothing but a counting sort which I explained in the last video. Okay, so after sorting, you need to position. After sorting, you need to position. So this is nothing but the concept what we got. Sir, can you please confirm if you are okay with this new list? I will go with the next approach. Can you please confirm everyone? Is it clear up to this whatever I covered, friends? Please confirm.
Yes, sir.
Right. Let us go for the next process. Sir, now you have to sort this based on tens position. Sir, which are there in tens position? 3 and then 1 and then 2. Here 3. So here also 3. Here 5. Here 9. Here 8. Here 0. These are in one's position. Okay, I mean tens position. We have to sort according to that particular. So we have to identify the numbers which are having 0 as a tens position. 009 is there. There is no other zeros. And if you talk about 1, so triple 1 is there. Okay, so no other data with 1. Then if you take next digit, triple 2 will come. So next 230 will come. So next triple 3 also will come. So next 034 also will come. Next any other digit having 4? No. Any other digit having 5? Yes. Any other digit having 6? No. Any other digit having 7? No. Any other digit having 8? Yes, we have. Any other digit having 9? Yes, we have. Like this it will be there. Okay, so how we got this particular list, you know very well, based on what technique I sorted this. So based on this tens position, based on this tens position, I got this particular list. This is nothing but the second phase. So this is nothing but what, based on tens position. Now, since it is a 3-digit number, we have another digit is also there, which is nothing but 100th digit, 100th position, which is nothing but 0, 1, and we have 2, another 2, another 3, another 0, another 4, another 8, another 9. Like this we have, I mean 0. So now we have to sort according to that. Sir, how it is going to be sorted? If you take so 009, if you take we will get 009. So next, any other digit having beginning with 0, 034. Any other digit having beginning with 0, 098. I think there is no zeros at beginning. And any digit which is starting with 1, triple 1. Any digit starting with 2, triple 2. Then we have 230. Then starting with 3, so triple 3. Starting with 4, 456. So starting with the 5, there is no digits. 6, no digits. 7, no digits. And 8 we have. Now what will happen? I can say this is nothing but my final result, sir. This is nothing but what? My final result. So we sorted according to which position, based on which position? Hundreds position. So do you know the final output what we are going to get here is after removing, okay, after removing that extra zeros, I am going to take 9, 34, 98, triple 1, triple 2, and then 230, and then triple 3, and then 456, and then triple 8. Just for our convenient purpose, we have added 0. In the program, we won't do that. If you ask, if you have a number called 9, what is the unit position digit? 9. What is a tens position digit? We don't have any tens position digit. It will return 0. Okay, like that we are going to get. Just for our understanding purpose, we have implemented. So do you know this algorithm, whatever I explained, is nothing but what? A radix sort algorithm what we have. I think you people got very clear clarity about this. Can you please confirm any doubt on this radix sort method? I mean theoretical approach, whatever we have.
No, sir. Clear.
Sir, hello.
Yes, yes.
Sir, why didn't we directly move to hundreds position and then we directly we will get the directly the output.
How?
Sir, because means if we see that 009 means the first list which you took, the numbers you took, sir, 45623009833.
Mm, mm,
So if we directly take the 100th position, so
mm.
we can directly take 009, then 034,
No, no,
then
no, no. How
098.
you will take? See, this is the list which we have given, right? This is the list which we have given.
Okay.
This is the input list, right?
Yes, sir.
If you take a 100th position, this is 4.
Okay. Sir.
This is 2. This is 0. Which one will come first? 0, right?
Yes, sir.
So you will take 98. Then the lesser values are there which are less than 98. The lesser values are there which are less than 98. Getting the concept?
Okay, okay.
Directly we can't take, sir. We have to start counting from 0th position onwards. This is the technique what we have. Okay.
Okay.
Right. So now we will write code for this. Of course, the code is a bit tough concept. Please try to understand. So what we are going to do in this implementation is compulsory we have to use internally counting sort. So I'm going to write first radix sort method. So this method is going to take a list and I'm going to find out the maximum element in the list because you need to identify the digits, right? That's why I'm finding the maximum element is equal to means maximum value in the list. Then I'm going to consider initially the position. Initially the position is nothing but unity position 1. So while your maximum element is there, right, divided by that position is greater than 0 not or not, we are checking. If it is greater than 0, I am calling counting sort method by passing the list and then by passing the position. And your position will become, so position into 10. This process we are going to repeat. Let us have an example. Sir, I have a list is there with some elements. I have a list is there with some element something like 329. Okay, so 888 and then 43 and then 3 and then 20, like this we have. So what we are going to do? We are identifying the maximum element. What is the maximum element? 888. So now position is equal to 1. Initially, what is the value of a position? It is equal to 1. I can say it is a unit position. So I am dividing 888 by position. What is the output that we are going to get? 888. Is it greater than 0? Yes. Then perform counting sort operation based on this position. Okay. So after doing this, then what we are going to take is position is equal to position into 10. So now your position value will become 10. Now we are going to check, is 888 divided by 10? What is its value? 88. So is it greater than? Is it greater than the position, sorry, 0? Yes, condition true. Second time this counting sort is going to work for position is equal to 10. Then again your position will become position into 10 means 100. So divide 888 by 100. What output we are going to get? It is nothing but 8. Is it greater than 0? Yes. Perform counting sort one more time based on this position. Then your position will become 100 into 10, which is nothing but thousands position. If you divide 888 with 1000, the output what we are getting is nothing but 0. Is 0 is greater than 0? No, condition will become false. That's why how many times it is going to run? Only 3 times. So because in this entire list, the maximum element which we occurred is nothing but 888. That's why it is going to run how many times? 3 times. Because we have 3 digits are there. So this is nothing but how internally this radix sort is going to take counting sort. Anyway, I will implement the counting sort. Of course, we know already. Can you please confirm, is the outline is clear for you people? Please confirm.
Yes, sir.
Right. Right. So now what I am going to do is I will implement the counting sort function also. So DEF, I am taking counting sort. So here we are going to take list and then position. So I'm going to take initially output. The people who attended the previous class in the counting sort, I think you got the idea how counting sort is going to work internally. I am preparing an output array with how many elements? 0 into length. Length is nothing but if your list having the length 5 means we are creating an output array with 5 elements. So after that, what we are going to do? We are going to create one count array. Count is equal to, I am taking 0 because in the counting sort we know exactly we have 0 to 9 digits are there. That's why in the count method, I'm going to take 0 into 10. Exactly 10 digits are there. Next, what we are going to do for each I value in the range of, for each I value in the range of 0 to length of L. Okay, we are going to take one by one item and we are finding the position. How to take the item? L of I double slash position percentage 10. Sir, in the first example, if you see, I think this one also double slash. So if you see in this diagram, we are sorting based on the position. Here, what is a position? So it is nothing but unit position is a 6. How to get this particular digit? I am dividing L of I. Here L of I is 456. 456 divided by position. First time the position is 1. 456 divided by 1 means we will get 456 only. Percentage 10 means we will get 6. So that will become your index. In the counting sort, we are incrementing the count array based on that index or not. Yes, that count will become already available count index plus 1. Okay, already available count index plus 1. We are going to just increment that counter value. Beyond that, nothing. I think here count index plus 1. Like this, we are taking. Sir, now what we have to do? You need to, we have incremented this and we are going to take another loop to update this value. Already I explained in the last video about this. So what is that? Is nothing but count of I will become already existing count of I plus we are going to take a count of I minus 1. So the people who attended the last class, you can imagine how we have updated this count array. I think the diagram is there somewhere. Let me cross check. Somewhere counting sort is there. You can see I updated the counting array. I updated the counting array based on the previous value. Here you can see. So that's what we have performed here. So after this, what we are going to do? We have to perform our actual operation. What is our actual operation? So here I am going to take index is equal to length of the list minus 1. So in the reverse operation, we are going to take in the counting sort how we got the values from the last index. We are subtracting and we are deciding in which position that particular element is going to occur. That's why while your I value is greater than 0, your index value will become as usual formula length of I divided by position percentage 10. I am going to take index value and in the output that the count of index is there, right? Its value minus 1 is nothing but that list of item. I am placing the item in output array where we are placing that corresponding count is there, right? In that particular position I am going to take. And after this, what we have to do in the count array, we have to reduce that index value because one value we captured, right? That's why count index is equal to count index minus 1. And similarly, your I value will become I minus 1 to get the next element. Like we are going to fetch the all values. So now the output array contains, so our result in sorting order on first digit, based on first digit, that is unit position. And in the count array, what how many times that particular digit is occurred, that maintained in the count array. So now both are updated. Now your output is nothing but we have to return or we have to copy that output into your original array, which is nothing but a list. So what I am going to do is for each I value in the range of, for each I value in the range of 0 to length of L. So what I am going to do is your L of I will become output of I. Like this, I am going to copy. Whatever elements are there in the output array, it will copy. So here, just for our convenient purpose, I am taking a list with the elements. So 319, 319, so 212, 6, and then 8, and then 100, and then 50. Like this, few elements I have taken. So first I will print the list, and I will call which method? Radix sort. Radix sort method I am calling by passing this list. Let us execute. Really, is this radix sort is working or not? We will cross check. Let us see how it is going to work. Py space test.py. L is not defined. Do you mean L? So somewhere we have written spelling mistake. Now let us see how it is going to work. Now you can see the data is arranged in an ascending order or not? Yes. For convenient purpose, let us take this example and we will trace out. Okay. Please look into very clear clarity. You will get. So initially my list is nothing but what? So 319, and then we have 212, and then we have 6. 6 means I will write in the form of 006. So then I will take 008. Then we have 100, and then we have 050. So I will explain for one pass, remaining things you can take. So here position is nothing but initially what? Your position value will become 1 unit position, right? That's why. So now I'm creating an output array with how many elements? Length of the list. 1, 2, 3, 4, 5, 6 elements are there. I will create a count array. So sorry, output array which is going to hold how many values? 3, 4, 5, 6, 6 values. And I will create a count array. So how many elements will be there? We have to take 10 elements. We have to take 10 elements. With that 10 elements, I am creating an array. So 0th location, first location, second location, third location, fourth location, fifth location. So 6th location, 7th location, 8th location, 9th location. So 0, 1, 2. So 3, 4, 5, 6, 7, 8, 9. Like this we will have. Now what we are doing, we have these two. For each I value in the range of 0 to length, we are taking one by one item from the list. Okay. So L of I, this is the first item, right? L of I divided by position percentage 10. We will get index. What is that index that we are getting? 9. So in count of 9, what element is there initially? 0. That 0 plus 1. So this count will become 1. Next we got 2, count will become 1. Next we got 6, count will become 1. Next we got 8, count will become 1. Next we got 0, count will become 1. We got another 0, count will become 2. Like this we are doing with the help of this loop. What is the next loop? We are going to update, because how many zeros are there? We know 2 zeros are there. How many 2s are there? We know 1 2 is there. How many 6s are there? We know 1 6. How many 8 1s are there? We know, that is, sorry, how many 8s are there? We know 1. How many 9s are there? 1. So we have to fix the position. Remaining values are 0, right? That's why. So count of 1. Don't take this 0th location. Start from 1. So count of 1 will become what? So count of 1, that is 0, plus count of I minus 1, 2. 2 plus 0 will become 2. That means what? Here we don't have any element. Two values are there. One value will be occupied here. One value will be occupied here. Because so these are the two numbers which are having 0 at the ending, right? So these are the two positions for that. Next, what will happen? So this value is going to update by taking the previous value is 2, current value is 1. So its position will become 3, and its position will become 3. Its position will become 3. Its position will become 3. Its position will become 4. So its position will become 4. Its position will become 5. Its position will become 5 plus 1 6. Like this we are going to take. We are depending on our previous value. So this is nothing but how we updated. Now the actual cinema is going to start. I am writing in the red color. Please concentrate. I is equal to length minus 1. What is I value? Length of the list is nothing but what? 1, 2, 3, 4, 5, 6 elements are there. Now L of I, L of, sorry, 6, 1, 0, 1, 2, 3, 4, 5. 5 will be there. So L of 5 I am taking. What is that element? 50. This element I am taking. I am trying to find out the index. What is the index? 0. Now output of count of index. Count of index value is what? 0. Count of 0. Count of 0 is 2. So 2 minus 1. Okay, count of index. Index value what we got here is nothing but L of I, that is nothing but 50. 50 percentage 10 means we will get 0 only. So your index value is 0. Count of 0 is nothing but 2. Sir, 2 minus 1. So output of 2 minus 1. 2 minus 1 will become 1. In the output, in the first location, okay, in the first location, we are trying to place that 0. In the first location, we are trying to place that 0. 50 will come here. Next, what we are doing, count of index will become count of index minus 1. Already it is 2, right? Now 1 0 ending element we copied. That's why your count will become 1. Then I is equal to I minus 1. Next time your index is 4. Select the next element. So what will happen? We are going to find out the index. Your index value will become 0. So output of count of 0. What is a count of 0? Now we have 1. 1 minus 1 will become 0. In output of 0th location, we are putting 100. Then I minus 1. I will become 3. Take the next element, third element. So index is nothing but 8. Right? Position is nothing but index value is nothing but 8. Count of 8. What is the count of 8 value? 5. Okay, so 5 minus 1. That is in fourth position, we are going to place that element, which is nothing but 0, 0, 8. So now what we are doing, your count value will be decremented by 1 unit. Next element what we are getting is 6, ending with 6. So count of 6, 4 elements are there. 4 minus 1. In third location, we are trying to push that particular 6. So then this value will be decremented by 1 unit. Now what we are doing, your index value will become 2, 0, 1, already 2 completed. This value will come. Your position will become 2. Your index value will become 2. So count of 2 is nothing but what? 3. 3 minus 1 means 2. In second position, we are going to place that element called L of I. So where it will be pushed to 1, 2. Next, this value will be decremented by 1 unit. Then again, we are going to run for the first location where your index value will become 9. Count of 9. What is the count of 9? 6. 6 minus 1 means 5. Count of 5 will become that element. Like that we are going to update. Sir, these are going to tell its positions, sir, where it is available, that position it is telling. Okay, like that we have. That means what? 0th location is available in 2 positions. Okay, so second next element, what is that next element to 2? It is available in these positions and these are empty. Like that we are going to tell. If you see, so if you sort according to the order, which one will come first? Which one will come first? So 100 will come first and 50 will come first. Next, any number ending with 1? No. Next, number ending with 2 is there. Number ending with 3 and 4 are not there. Number ending with 6 is there. Number ending with 8 is there. Number ending with 9 is there. Like this we will get. So after first pass, is it our list or not? Yes. So this process we have to take for position is equal to 2 also. I think you people understood how internally it is going to work. Can you please confirm? Any doubt, friends, up to this? Please confirm, everyone.
Yes, sir.
But I request everyone, if you take this in the paper and pen by taking multiple examples, then only you can able to understand this. Okay. Otherwise, it is very difficult for you to trace. Clear up to this? Please confirm. Right. This is nothing but what we have about radix sort algorithm. Okay. I think the code is executed successfully, right? This is nothing but what we have. So anyway, the remaining things I'm going to cover tomorrow. So with this, almost the sorting techniques, main sorting techniques, we finished. Which sorting techniques we have seen? So we covered bubble sorting technique. So next we have seen selection sort. Next and after that we discussed about insertion sort. Next we worked with something like counting sort. Then we implemented radix sort also. So many sorting algorithms are there, but these are sufficient. So with this, I will give some assignment for you people in the tomorrow's session with some 5 programs you try to implement. Okay. So I will give problems based on sorting in the tomorrow session. So with that, these sorting techniques are going to be finished. So after this, before moving to the searching techniques, I will try to implement divide and conquer technique, because in the divide and conquer algorithms, we are going to get merge sort and quick sort. So I need to talk about that merge sort and then quick sort. Okay. That's why we will talk about this divide and conquer algorithms. Later we will go for searching. Maybe this week completely we will concentrate on divide and conquer. It is very easy, sir, not that much difficult. We will discuss about that introduction tomorrow session. Okay. So this is nothing but what we have in today's session, sir. We will meet for the continuation tomorrow. I will upload the running notes within few minutes. You can able to download. Okay. Right, sir. Thank you.
Thank you, sir.
Right.